So today we start on the dosage calculation part of the course, probably the most important part for many of you. We're going to start out with a little bit of a review of ratios. And I'm going to use an example of my Fridays. On my Fridays, if I'm looking at what I have for students, I actually have 3 different classes, but 2 of them are math for health, and 1 of them is construction. So I'm going to do a ratio of health students to construction students. And between my 2 classes of the math for health professionals, I have 27 students. In the construction class, I have 9 students. Now I can write it as a ratio like that, or I often like to write it like this, as a fraction. And as a fraction, we can reduce that similar to what we would with most fractions. Both the 9 and the 27 can be divided by 9, which gives us a 3-to-1 ratio. Now, unlike fractions, we leave that as 3-to-1. We would not make that just a 3, because we still have to have that comparison between 2 numbers. But anyway, hidden in this ratio, there are 2 other ratios. Currently this is students in the math for health and students in the construction math course. But I also have the ratio of students in the health math for health to total students on Fridays. That would be still using the 3 for the math for health. What number would go in there to represent the total number of students? Well, if I go back to the beginning here, there you go. If I use 27 for the math for health, 27 plus 9 would be 36. So now I reduce that to get the 3 over here, divided by 9. If I divide by 9 with the 36, I'm going to have 4. So that saying is, if there's a ratio of 3 health students for every 1 construction student, well, then there's 3 health students for every 4 total students, just adding the 3 and the 1 together to get a total. I could have done a similar thing to do a ratio of construction students to total. So what we're looking at today is something called a dilution. A dilution is where you take a concentrated medication, or what we're going to call the serum, and you add something with no medical value, which we usually refer to as NS. Remember, that had several meanings. It can be neutral solution, normal saline. Basically, it's sterile water, something with no medicinal value at all, that is just supposed to dilute down the medication. And in a dilution is a ratio of the parts of concentrate or serum to the total parts. For example, if we create a 1-in-6 dilution of medication in saline, there are 3 ratios created here. First is the dilution itself, 1-in-6. Now remember, the dilution is the ratio of serum or concentrate to total. So the 1 represents the amount of serum or the amount of concentrate, and the 6 represents the total parts of the solution. If I wanted to make the ratio of serum to saline, what's that going to look like? Well, we still just have 1 part of serum. If we had 6 parts total and 1 of those parts is serum, how many parts are saline? 5. Very good. So we can create a ratio of serum to saline from that dilution ratio, serum to total. And there's one other ratio we can get out of that yet. We can get the saline to total solution. Well, we've already figured out how many parts of saline there are. There are 5 parts to 6 parts of total solution. Which makes sense. If 1 out of 6 parts is saline, or sorry, if 1 out of 6 parts is serum, the other 5 out of the 6 parts has to be saline. So let's say we are going to create 420 milliliters of 1 in 6 dilution. Of serum and serum. How much of the medication, how much of the serum, and how much saline will be used. So we have 1 in 6 dilution again. So that's 1 in 6. Whenever I'm working with dilutions, though, in order to help me keep my mind straight, I always label this ratio when I write it out. The 1 represents what? Parts of serum. The 6 represents total parts. It's really easy to say that the 6 represents saline. That's what most people want to jump to, but it always represents the total parts when it's a dilution. So up in the rest of the problem up here, do we have a number that represents either the serum or the total? Yeah, we want to create 420 milliliters of that dilution. 420 milliliters is the total amount of solution. So that's going to go on bottom with the total. And we will cross multiply and divide. 1 times 420 divided by 6 is 70 milliliters. What's that 70 milliliters represent? That's serum. That's our medication. So we need 70 milliliters of serum. Now are we done answering the question? We answered how much serum, but we also need to know how much saline. Very good. 2 ways we can go about this. 1, of course, we know there's 420 milliliters total. We subtract 70 milliliters. That means there's 350 milliliters of saline. Or we could look at using the ratio of saline to total. If 1 out of 6 parts is serum, the other 5 out of the 6 parts must be saline. So that would be the ratio of saline to total. The 420 still represents the total, and if you cross multiply and divide, you will get 350 milliliters again. I always like to use the ratios, and then that way I have the ability to double check by adding the 2 numbers together to see if it adds up to the total. But it is just fine to go ahead and subtract like this. So let's say when creating a 1 in 8 dilution of insulin in water, if 240 milliliters of solution is needed, how much insulin and how much water are used? You guys talk me through this. Where do I start? So 1 to 8, that is our serum to total, so that's insulin in this case. So total solution. Okay. What's next? Let's go on back. 240 milliliters is the total solution, yes. And then cross multiply and divide with 30 milliliters of insulin. And of course, we'll take the short route. 240 milliliters minus 30 with 210 milliliters of water. So for the next example, how much of a 2-in-9 dilution can be created with 14 milliliters of serum? Well, you should be seeing a pattern. We're always going to start out, of course, with the dilution, the 2-in-9. And I like to always label them. The 2 represents the serum and the 9 total solution. Looking up here, we have the 14 milliliters. What does that represent? That's your serum. So that goes up here with the 2. Now, whatever we get here will be the total solution. Is that what we're looking for? Yes, it is. So we'll cross multiply 9 times 14 divided by 2. Looks like we can create 63 milliliters of solution. Slightly different question. How much sterile water should be mixed with 24 milliliters of serum to create a 3-in-7 dilution? So we'll start out with the dilution again, 3-in-7. The 3 represents serum and the 7 total solution. Do we have either of those numbers? Yeah, we have the 24 milliliters of serum. So we have that. Do we have the total solution, or are we looking for the total solution? No, we're looking for the amount of NS. So we need a ratio that has serum in it, but we don't need the total solution. We need a ratio that has the saline in it. So we're going to do the ratio of serum to saline. Well, the serum is still going to be 3 parts. How many parts of saline will there be? There we go, 4. If there's 7 total parts and 3 of those parts are serum, 7 minus 3 leaves 4 parts that have to be saline. And now we can go ahead and put the 24 milliliters of serum up top with 3, and we'll cross multiply and divide. 4 times 24 divided by 3 is 32 milliliters of saline. You could have on this one, if you wanted to, if you didn't want to adjust the ratio, you could have used the 24 milliliters. You have cross multiplied and divided to get 56 milliliters of total solution, and then you'd have to go back and subtract 56 minus 24 of serum and get how much left must be saline. So there's more than one way to approach each of these problems, but it's easiest in many cases to be able to adjust the ratios. So for a 3 and 11 dilution, find the ratio of serum to saline. Just to practice adjusting that ratio a little bit. I always write out the dilution, so I have something to start with. It's 3 and 11. Of course, the 3 is the serum, and the 11 is total parts. We want serum to saline. What numbers are going to go in that ratio? 3 over 8. Very good. Still 3 parts of serum. If we had 11 total parts, take out the 3 parts of serum, there's 8 parts left over that have to be saline. So 3 and 8. So one for you to try in your seats here. How much of a 1 in 9 dilution can be created? Using 240 milliliters of saline. I'm going to pause it for a second, give you guys... So looking at this, our dilution is 1 in 9. And of course that is serum to total. We want to know, we know that we're going to be using 240 milliliters of saline. Well, this ratio right now does not have saline in it anywhere, so we need a ratio of saline. So do you want saline or serum to saline, or do you want saline to total? Well, we want to know how much of the total solution can be created. So we want saline to total. What's that ratio going to be? 8 over 9. Good. If 1 out of 9 parts is serum, the other 8 out of the 9 parts must be saline. So now then we complete our ratio, or complete our proportion. The 240 is the amount of saline that goes on top. And we can cross multiply and divide. 9 times 240 divided by 8 to 270 milliliters of total solution. Oh, let's see. Let's say we have 80 milliliters. I'm sure I'm going to butcher the spelling here, but yeah, we'll go this way. 80 milliliters of urine is diluted with 200 milliliters of sterile water. Find the dilution. So what is that dilution? I'll give you a second. So when you look at this one, you have to recall that the dilution is parts of serum, bless you, to parts, total parts. We have the parts of serum. In this case, the 80 milliliters of urine is our concentrate. Do we have the total parts? No, we have 200 milliliters of saline. So put in the 80 milliliters for our concentrate, the serum. 200 milliliters of saline will combine with the 80 milliliters of urine to give us 280 milliliters total solution. So that's what has to go in here. And of course now, both of those can be divided by 40. Give me a 2 and 7 dilution. How's everybody doing with these so far? Not bad? Oh, let's see here. Let's do this. 360 milliliters of solution is created using a 1 to 10, sorry, not 10, but 1 to 11 ratio of serum to saline. Find the dilution and the amount each of serum and saline. I'll give you guys a second to try to work that one. Let's take a peek at this one. So it's a 1 in 11 ratio of serum to saline. But one of the things we need to find is the dilution, which of course is serum to total. What's that going to end up being? 1 to 12. Very good. Still only 1 part serum, but we have the 1 plus the 11 to make 12 total parts. Now we want to know how much serum and how much saline are used. Well, now that we have the dilution of 1 to 12, we can use that to find the amount of the serum in 360 milliliters of total solution. So cross multiply and divide. That gives us 30 milliliters of serum. Now we could subtract, or I'm just going to go ahead and do this quick. I'm going to do saline to total, which would be 11 out of 12. Cross multiply and divide is going to give me 330 milliliters of saline. So one of the things these dilutions are used for, I mean, it is used for diluting medication so that it can be administered with a larger amount of fluids. Another common place is in urine and blood testing. Let's look at blood glucose for a second. When doing a blood glucose test, the meter has a capacity of less than or equal to 800 milligrams per deciliter of glucose in the blood. What that means is if the level of glucose in the blood goes over that 800 milligrams per deciliter, the meter can't read it. The meter will freeze up. It'll give you an error message, an outer range message. Which also, if you're over 800 milligrams per deciliter, you're in trouble anyway. But it does happen. So anyway, let's say that you do that. You do run a blood test, and it gives you that message that it's out of range of the meter. So what are your options? Well, in this case, we are going to take 20 microliters of blood, mixed with 60 microliters of some sort of a neutral diluent. We're just going to put down NS, or neutral solution again. It is retested now, and the level we get is 290 milligrams per deciliter. So we want to know what is the actual value of this reading, now that we got the diluted reading of 290 milligrams per deciliter. Well, the first thing we have to do is we have to figure out what the dilution is. So remember, the dilution is serum to total. We have a 20 to 60 ratio up here. Is that the dilution? No, that's the serum saline. The actual dilution itself is 20 to 80. The microliters are going to cancel out, so I don't bother to put those in. And this will be reduced. Both of those can be divided by 20 to give me a 1 in 4 dilution. Now that we know the dilution of the blood, we can adjust the levels. We have this 1 to 4 ratio. And we have that 290 milligram per deciliter reading. Is that 290 going to be the small number or the large number in what we're looking at here? It's going to be the small number, the diluted number. The actual reading is going to be larger than the 290. So that tells us that in our proportion here, the 290 has to go on top. Because the number we're looking for, the actual reading, is going to be larger, so that's going to be on bottom with a bigger number. So we will cross multiply and divide here. We'll get 1160 milligrams per deciliter. Anybody know where what blood sugar level you start to go into hallucinations? Well, I know at 500 you start to have inhibited mental capacity. You have hallucinations and then unconsciousness. Yeah. Yeah. Well, see, I'm one of those people. My blood sugar levels are naturally around 140 to 150, but I'm not diabetic. Yeah. Okay, so anyway, so that's one way we can go about it. In this case, we just diluted it with a certain amount of neutral solution, and then from there we figured out our dilution and everything else. Let's go ahead and do another example. I'm going to put it up here for you and let you guys try it. So again, we're going to assume we exceeded the meter. And in this case, we are going to take 30 microliters of blood. And we are going to perform a 1 in 5 dilution. Our diluted reading is 173 milligrams per deciliter. So I want two things I want to know. One, how much of neutral solution was used, and then what is the true reading. I'll give you guys a second to see if you can figure that out. So for this one, the true reading is probably the easiest part of this to figure out. If we're going to do a 1 in 5 dilution, how do we find the true reading? 173 is going to be the smaller number, so it goes on top with the 1. Cross multiply and divide. 5 times 173 divided by 1 is 865. Is that right? Because it exceeded the meter, which tells us that it had to be over 800. So now, how much of the neutral solution did we have to add? Well, it was a 1 in 5 dilution. And of course, the 1 represented the serum, in this case the blood, and the 5 represented the total solution. We want to know how much saline, so we're going to make this a ratio of blood to saline, which is going to be 1 to 4. So for every 1 part of blood, they needed 4 parts saline. So now we have the 300 microliters of blood, or 30, sorry, 300. 30 microliters of blood goes with the 1 for the blood. We cross multiply and divide. That means there's 120 microliters of saline added to it. So let's say we have a 40 milliliter sample of urine. Is diluted to a total volume of 200 milliliters. It is tested, I won't say for what, it is tested and results in a reading of 43 milligrams per deciliter. Find the true reading, or the full reading. Talk me through this one. What do we do? You notice each of these has been just a little bit different. Okay, so we're going to do the 40 over 200. The 40 represents the urine, and the 200 does represent the total volume. So that is going to be our dilution ratio. So the milliliters cancel out. Both of those can be reduced by 40, giving us a 1 in 5 dilution. What are we going to do with the 1 in 5? Okay, the 43 goes on top. Again, that is the diluted value. That's after we've diluted it with water. So we know that value is going to be smaller than the true value. And we'll cross multiply and divide. 5 times 43 divided by 1 is what? 215 milligrams per deciliter. Okay, in our next step, we're going to start looking at what if we don't have a pure serum? What if we already have a diluted serum and we're going to dilute it further? So let's say we have 72 milliliters of, we'll go 30% solution. And we are going to take that, we're going to perform a 1 in 6 dilution. Find the new concentration. The concentration is just the percentage of the total solution, that is the serum. So what we started out with here was only 30% serum. So I'm going to take a look at that quick. 30%, or 30 out of 100, of that original 72 milliliters was serum to begin with. So if I cross multiply and divide, 30 times 72 divided by 100, what is that, 21.6 milliliters? Is that correct? So there's 21.6 milliliters of serum to begin with. Now it undergoes a 1 in 6 dilution. Now a dilution, we're adding stuff with no medicinal value. We're adding that sterile water to it. So we had 72 milliliters. After a 1 in 6 dilution, the 72 milliliters, remember 1 in 6, the 1 represents the concentrate or the serum, and the 6 represents the total. So the concentrate is going to be that 30% solution. And we had 72 milliliters of that. So after the dilution, we are going to have a total, 6 times 72 divided by 1 is going to be, what, 432 milliliters, I believe. So we now have a total of 432 milliliters of solution. What is the new concentration? Well, we had 21.6 milliliters of serum. Now we have 432 milliliters of total solution. what percent is that going to be? We'll cross multiply and divide. 100 times 21.6 divided by 432. Is that 5? I believe. Yep. So that new concentration is now 5%. Now what I just did there is a lot of math, a lot of work to prove a very simple concept. We took a 30% solution through a 1 in 6 dilution, ended up with a 5% solution. Anybody see a relationship there? You just multiply the percent by the fractional dilution. 30% times 1/6 is 5%. Another way to look at it is the dilution ratio is equal to the new concentration over the old concentration. So if we have 36% solution and we need 8% solution to find the dilution necessary, well, which one is going to be the new percent? 8. Generally the smaller percent, right? And the 36% is going to be the old percent. Of course, the percent cancels out. Both of those can be reduced by 4 to give us a 2 in 9 dilution. So a 60% solution is diluted 3 in 8. Find the new concentration. Tell me what to do. It's a lot easier than it looks. Perfect. 3 in 8 dilution is 3/8. 60 times 3/8 is 180 over 8, which divides out to be 22.5% solution. That looks like a good spot to take a break.